Hi kids, in this video we'll continue with sums from Theorems on area from M L Aggarwal. This is class 9, exercise 14. We have already done till sum number 5. You can click on the I button and get the link. Let us start from 6a. They are told in the figure ABCD is a parallelogram. P and Q are any 2 points on the side AB and BC respectively. Prove that area of triangle CPD is equal to area of triangle AQD. Let us see. First of all, if suppose ABCD, I take AD as a base of this triangle AQD, then area of triangle AQD will be half area of parallelogram ABCD. Remember, we have done a theorem that the area of a triangle is half the area of a parallelogram with same base AD and between the same parallels. Remember, suppose this is your parallelogram AB. I'm writing over here, suppose AD, this is BC. Then AD as a base, I draw a triangle, suppose AQD. They have the same base AD and they are between the same parallels, which means area of ADQ will be half of ABCD. Isn't it? That's the theorem. Area of a triangle is half the area of a parallelogram with the same base or equal base and between the same parallels. You will write the theorem over here. I've already explained the theorems, okay? Then again, if you look carefully, I'll just draw the same diagram like this. Look over here. Just look. A, B, C, D. A, B, C, D. Then with DC, I have P. C, P, D is a triangle. Now, area of this triangle again will be half of area of ABCD. They have the same base and they are between the same parallels. Look carefully. So I can say area of triangle CPD is half area of parallelogram ABCD. Same theorem that area of a triangle is half the area of a parallelogram having the same base or equal base and between the same parallel lines. Done. Now from these two, we can definitely say that the area of these two triangles are same, because this is equal to half of area of ABCD, this is equal to half of area of ABCD, which means from these two above we can say that area of triangle AQD is equal to area of triangle CPD and AQD. This is what we were supposed to prove. Done. Very easy. Just look at the diagram carefully. Now let us look at 6th part B. Now look at 6th part B. In this figure given below, PQRS is a parallelogram and ABRS are parallelograms. And X is any point on side BR. Show that area of triangle AXS is equal to half the area of parallelogram PQRS. Very easy. Look over here. Area of AXS. First of all, don't you think area of parallelogram PQRS, just a second, area of parallelogram PQRS is equal to area of parallelogram ABRS. Why? We had a theorem that area of two parallelograms having same base, see over here, they have same base SR. Yes or no? Area of parallelograms having same base and between same parallels are equal. That's the theorem, remember? You will write the theorem over here. I've explained all the theorem. Okay. So they are between PB, look over here, and SR, and they have the same base, which means area of PQRS and ABRS will be same. Now look carefully. Just now we did area of a triangle is half the area of a parallelogram having same or equal base and between the same parallels. Look at the parallelogram ABRS. Look, I'm drawn over here. ABRS. If suppose AS is your base and you draw a triangle AXS, the area of this triangle is half the area of ABRS. So can I say area of triangle AXS is half area of parallelogram ABRS? What is the theorem over here? That area of a triangle is half the area of a parallelogram having same base and between same parallels, between same parallel line. Yes or no? Now, so area of triangle AXS is half area of parallelogram. Now look carefully. Instead of ABRS, I can write PQRS because both the areas are same. That's PQRS. And this is what we were supposed to prove. Now we have used two theorems. First one, area of two parallelograms having the same base and between the same parallel lines are equal. Second, area of a triangle is half the area of a parallelogram provided the base is same or equal and they are between the same parallel lines. Done. Now let us look at number, this is 6. Now look at number 7. D, E, F are the midpoints of BC, CA and AB respectively of a triangle ABC. Prove that FDCE is a parallelogram, area of triangle DEF is 1/4 area of triangle ABC, and area of parallelogram FDCE is half area of triangle ABC. First of all, draw the diagram. Look over here. You have a triangle. Okay, try to understand. A, B, C. They are told D is the midpoint of BC, E is the midpoint of CA, and F is the midpoint of AB. Okay, this is their given. First thing, let us join this. Okay, now look carefully. First thing, required to prove what? FDC is a parallelogram. FDCE is a parallelogram. Now just remember midpoint theorem, what we did. You know, F is the midpoint of AB, E is the midpoint of AC, which means by midpoint theorem we can say that F and E are midpoints of AB and AC respectively, which simply means that by midpoint theorem FE is parallel to BC and FE is equal to half of BC. Half of BC. Now D is the midpoint. So BD and DC are same. So half of BC is nothing but DC, which means can I write FE equals to DC, which means this and this are equal and they are parallel also. Yes or no? Similarly, look, F and D, you know, F and D are midpoints of AB and BC respectively, which means FD is parallel to AC by midpoint theorem. This is midpoint theorem, yes or no? And FD is half of AC. Now half of AC is EC. Why? Because E is the midpoint of AC. So AE and EC are equal. So half of AC we can write EC. So FD is equal to EC. Yes or no? So they are parallel to each other and this is equal to this. So hence we can say by these two, see opposite sides are equal and parallel, which means it's a parallelogram, which clearly implies from the above two, we can say that, what was the thing? Yeah, FDCE is a parallelogram. Suppose this is your 1 and this is your 2. From 1 and 2, you can simply say that because opposite sides are equal as well as parallel. Now look over here. Area of DEF, area of DEF, which means this one, is 1/4 area of triangle ABC. Now first of all, look over here. We just proved now that FDCE is a parallelogram, okay, and FD is parallel to AC and half of AC. FE is parallel to BC and FE is half of BC. Similarly, we can prove D and E are midpoint of BC and AC. Look carefully. Then can you say that by midpoint theorem DE is parallel to AB? Yes or no? Midpoint theorem, same logic. And DE is half of AB. F is a midpoint, which means this and this are equal. Done. Which means FEDB is also a parallelogram because opposite sides are equal. This side and this side is equal too, and parallel also, isn't it? And this side are equal as well as parallel. So it's a parallelogram. Now look at similarly this one, FDEA. FDEA will be a parallelogram, isn't it? Because this is parallel to this, isn't it? DE is parallel to this and DE is half of AB. DE is parallel to AB and DE is half of AB is equal to half of AB is AF, isn't it? Now look. So we proved that AEDF is a parallelogram, FDCE is a parallelogram, FEDB is a parallelogram. We have proved. Now look. If you look at this parallelogram, okay, FDCE, the diagonal bisects it into two triangles of equal area. These two triangles are congruent. So can I say area of triangle FDE, DEF, whatever, DEF is equal to area of triangle DEC, suppose x unit square. Suppose. Why? Because the diagonal bisects or diagonal divides the parallelogram into two triangles of equal area. Yes or no? So this is x unit square. Similarly, BDEF is a parallelogram. FD is the diagonal. So I can say area of FDB is equal to area of DEF. Same reason, equal to x because this is x, so this will be x. Reason is same. Yes or no? One more. Look at the parallelogram AFDE. This one. Same. FE is the diagonal. It divides it into two equal triangles, which means area of, again, DEF is equal to area of triangle AFE is equal to x. Yes or no? Now look carefully. X. All the areas are same. So area of triangle FDCE area of triangle FD, oh yeah, DEF, sorry, area of triangle DEF, number 2, area of triangle DEF is equal to X, and area of triangle ABC is 4X, isn't it? And area of triangle ABC, just look, 4X, yes or no? Just divide these two. So area of triangle DEF by area of triangle ABC, X by 4X, मतलब 1 by 4. This goes on that side, which means area of triangle DEF is 1/4 area of triangle ABC. Done. Second part proved. Okay. Now look, area of parallelogram FDC, which is 2X, is half the area of triangle ABC. Of course, because area of triangle ABC is 4X. So just we need to see. I'll do it over here. Number 3. Area of parallelogram FDCE. Look carefully, it is 2X. And area of triangle ABC, 4X. Divide these two. So area of FDCE by area of ABC is 2 by 4, that is 1 by 2. This goes on that side, which means area of FDCE is half into area of triangle ABC. That is what we were supposed to prove. Done. Very interesting sum. The parallelogram, first we proved that it's a parallelogram. 1, 2 and 3 parallelograms we got. Now the diagonal divides the parallelogram into 2 equal triangles, which means triangles having equal area, XX, XX, XX. Then the 2 part is very easy, second and the third. Done. Now let us look at the next sum. Now look at sum number 8, just like the previous one. See, the diagram is exactly the same. In the adjoining figure D, E, F are midpoints of side BC, CA and AB, which means this and this are equal, this and this are equal, and this are equal, because D, E, F are the midpoints. Prove that BCEF is a trapezium. And next, area of BCEF is 3/4 area of triangle ABCD. Very easy. What is a trapezium? In a trapezium, a pair of opposite sides are parallel and the other pair are not parallel. Just if we can prove that FE is parallel to BC, our work is done. It's a trapezium. Yes or no? Now look carefully. By midpoint theorem. Okay? Look. F and E are midpoints of AB and AC respectively, which means by midpoint theorem I can say FE is parallel to BC and FE is equal to half of BC. Midpoint theorem. Yes or no? Definitely. So this becomes parallel to this. Okay, so this simply implies FBCEF is a trapezium. Why? Because one pair of opposite sides are parallel. That is a trapezium only. Done. Number 1. Number 2. Area of BCEF, this trapezium, is 3/4 area of triangle ABC. Just now we did in the previous sum that FDCE is a parallelogram, remember? And if the area is X, we take it as X. BDEF is a parallelogram. The diagonal divides a parallelogram into 2 triangles having equal area, XX. Here also DE divides the parallelogram into 2 triangles of equal area. Similarly, DEAF is a parallelogram. So FE is the diagonal, it divides the parallelogram into two triangles of equal area. Now look carefully. Area of trapezium BCEF, if you look, XXX, that's 3x, and area of ABC 4x. Just divide these two. So area of trapezium BCEF by area of triangle ABC, 3x by 4x, 3 by 4. This goes on that side, which means area of trapezium BCEF is 3/4 area of triangle ABC. Just like the previous one. I'm not proving it. It's a parallelogram. I've already proved. If in the exam it comes, you have to prove them. Okay. So this is sum number 8. Now let us look at the next one. Look at number 9a. In the figure given, the point D divides the side BC in the ratio m:n. Okay, you need to prove that area of triangle ABD is to area of triangle ADC is m:n. Let us see how we can prove this. This is of course the perpendicular. Suppose this is AP, H. This is the perpendicular. Now, area of triangle ADC is half into base into corresponding height, that is H. Similarly, area of triangle ABD, look carefully, half into base. If the base is BD, the height is AP. You know, if this is a triangle, then you extend this, then this becomes your height, isn't it? Same thing. Now this is height is H. Just divide these two. So I'm writing this. This is supposed 2. This is 1. So 2 divided by 1. This will be at the top. So area of triangle ABD by area of triangle ADC is equal to half into BD into H, half into DC into H. Half cancels out, H cancels out. Now what remains? BD is to DC. Now BD by DC is given as m by n though. Already given. So this is m by n. Which means if you write this in ratio form, then area of triangle ABD is to area of triangle ADC is equal to m:n. Done. Clear? It was very easy. Okay. We just use this property, area goes to half into base into corresponding height. Done. Now let us look at number 9b. Now look at 9b. In the figure given, P is a point on the side BC of the triangle ABC such that PC equals to twice BP. PC equals to twice BP. Done. Then they are told, and Q is a point on AP. Q is a point on AP such that QA equals to 5 PQ. Find the ratio of area of triangle AQC and area of triangle ABC. Chalo, let us see. Look carefully. First of all, I am talking about this triangle ABC. Triangle ABC. PC is equal to twice BP, which means PC by BP is 2 is to 1, which means PC if I take BP as x, this becomes 2x. 2x by x is 2 by 1. Done. Now what do I do? Suppose this perpendicular from AD on BC, that's the perpendicular height H. Then area of triangle ABC, half into base. Base is BC. And how much is BC? X plus 2x, that's 3x. X plus 2x, that's BC, into height, which is AD, which is H over here. Now, area of triangle APC. APC. Just look over here. APC. Half into base, which is PC, into height, which is H. So this is 3xh by 2, and this is 2xh by 2. Done. Which means area of triangle APC is xh. So instead of this xh, can I write area of triangle APC? Which means area of triangle ABC is 3 by 2 times area of triangle APC. This is a very important relation which we got. Area of ABC is 3 by 2 times area of APC. Now, just look over here. AQC we want now. Look at this triangle APC. Okay. Now, from this C, what I'll do, I'll drop a perpendicular. I'll drop a perpendicular, suppose. Okay. CM. CM. Then area of APC. Area of triangle APC. Can I write half into base? If AP is the base, then the height is CM, isn't it? See now. This is your triangle. From here I have dropped a perpendicular. So if I take this as the base AP, then CM. So C, this is M, this is A, and this is P. CM is the height, which means CM. And in the same, you see AQC. Area of triangle AQC is half into base, which is AQ, into height, which is CM. Just look carefully. Done? What happened? This suppose is 2. This suppose is 1. 2 divided by 1. What I get? Area of triangle AQC we're getting by area of triangle APC is half into AQ into CM by half into AP into CM. CM, half cancel. What is left? AQ by AP. Now look carefully. What is given to us? QA is 5 times PQ, which means if you take PQ as K, then AQ becomes 5K, isn't it? Now look, instead of AQ, I'm putting 5K, and instead of AP, I can put 6K, isn't it? So K cancels out. Now from here, yes, from here, can I write area of triangle ABC multiplied by 2 by 3 is equal to area of triangle APC? I can write 2 goes up, 3 comes down. Now, just look over here. Area of triangle AQC is 5 by 6. This goes on that side. Area of triangle APC, yes or no? Now, instead of area of triangle APC, can I write 2/3 area of ABC? I can, because area of triangle APC is 2/3 area of triangle ABC. 1 time, 2, 3 times, which means 5 by 9 into area of triangle ABC. Yes or no? This was area of triangle AQC. Bring it on this side. So area of triangle AQC by such a lovely sum. Area of triangle ABC is 5 by 9, which means 5:9. Done. Very easy. If you understand the concept, you need to practice as much sums as possible. Okay. In the first, I got the relation between triangle ABC area and APC. In the second case, I got the relation between APC and AQC. Then I just substituted. Practice this sum at least 2 to 3 times. Then only you will start understanding the logic behind the sum. Done. Now let us look at 9C. Look at 9 part C. In the figure given, AD is the median, which means BD and DC are same. Of the triangle ABC, and P is a point in AC such that area of triangle ADP is to area of triangle ABD is 2:3. Find AP is to PC, AP is to PC, and then find the area of triangle PDC is to area of triangle ABC. Chalo, take it. Now, first of all, they want AP by PC. What is given to us? Area of ADP and area of ABD. The ratio is 2:3. First of all, D is the midpoint. AD is the midpoint. Now, remember the theorem? The median divides a triangle into 2 equal triangles, which means, can I write area of equal triangles means equal area. Area of ABD is equal to area of triangle ADC. Why? Because AD is the median, and the median divides the triangle into 2 equal triangles. Done? So this relation, what they have given us, area of triangle ADP by area of triangle ABD is equal to 2/3. Now instead of ABD, can I write ADC? Because the area is same. So I'll write area of triangle ADP by area of triangle, instead of ABD I'm writing triangle ADC, that is 2/3. Now area of ADP, suppose from D I drop a perpendicular H DM, then area of triangle ADP, is half into base ADP. Base is PA, isn't it? Or AP. Height H. And area of triangle ADC. Again, AC is your base and the height is H. That is 2/3. H, half cancel. Which means we got AP by AC is 2/3. Which means if AP is 2K, then AC is 3K, isn't it? Let AP equals to 2K, then AC is 3K. Then what is PC? PC is 3K minus 2K. Look, 3K minus 2K, which is K. Now the ratio AP by PC is AP is 2K by K, which means 2/1. That is 2:1. That's the first part. Clear? So the ratio is 2:1. Now what they have asked in the second part, area of triangle PDC, okay, by area of triangle ABC. Let us see ABC. Now area of triangle PDC by area of triangle ABC. Just look carefully. Now area of triangle PDC is half into base, which is PC, into height, which is H. Now area of triangle ABC is equal to twice area of ADC. Why? Because area of ABD and area of ADC is same. So the whole triangle, can I write this as the area of triangle ABC? Can I write twice into area of triangle ADC? Look carefully I can write. Now just now we did, this is half into PC into H. This is twice. Area of triangle ADC is half into base. Base is AC into height, which is H. Done. Now look carefully. This 2 cancels out. H cancels out. So this becomes half PC. PC we got as K by AC. AC we got as 3K. So that's K cancel out 1 by 6. So the ratio is 1:6. So area of triangle PDC by area of triangle ABC will be 1:6. Done. Very easy. Step by step. Area of ABC will be twice area of ADC because AD is the median. This area and this area is same. Then we had a relation, the length AP, PC, AC. We just utilize that. Step by step. You need to bifurcate the whole sum into small parts and then proceed. So in this video, keep it till here. In the next video, we'll see the rest of the sum. Till then, take care and be safe. And if you like the video, do subscribe and share.